Hello there. Here we have a problem. To solve x cubed add 1 equal to 0, then we need to find the 3 cube roots of negative 1. Secondly, we need to let one of the roots be lambda and express the others, or the other, in terms of lambda. And finally, to prove that 1 add lambda squared is equal to lambda. Now, I see this as 3 different parts, and so I'll do 3 different videos as 3 different questions. So first I'll solve this equation x cubed add 1 is equal to 0, and I'll find the 3 cube roots of negative 1. That's question, or part 1. Then on part 2, I'll let one of the roots be lambda and express the other in terms of lambda. And thirdly, prove that 1 add lambda squared is equal to lambda. So let's get started. If we have that x cubed add 1 is equal to 0, this implies that x cubed is equal to negative 1. So we have that x, one of our solutions, real solutions, is x is equal to negative 1. And if we apply the factor theorem, we have one of the factors be x minus a, which is x, minus 1, which is x add 1. So one of the factors is x add 1. So now we can write that x cubed add 1 is equivalent to x add 1, one of its factors. And if we divide x cubed add 1 by x add 1, we have x squared minus x add 1. Hence, we have that x is equal to negative 1, or we have x squared minus x add 1 is equal to 0. Which gives us that this part we'll use the quadratic formula, and we have 1 minus b, the coefficient of x, plus or minus the square root of 1 minus 4, all divided by 2. So now we have the roots of x cubed add 1 equal to 0 are negative 1. We have a half add root 3 over 2i, and the other a half minus root 3 over 2i. So there you have it. I've answered the first part here, and we'll call this part 1. I've solved this equation x cubed add 1 equal to 0 by finding the 3 cube roots of negative 1. They are negative 1, a half add root 3 over 2i, and a half minus root 3 over 2i. Part 2, I'll work on finding expressing lambda in terms of lambda. Thanks for watching. I'm Alistair.